or a belief in a fact. So the guess is typically the first thing that comes into a head. So a hypothesis, a proposed explanation, and one of my favourites is a conjecture, which is an inference based on inconclusive evidence. And they're good things, but you need to know that the evidence is inconclusive. And at this point, and then probable cause, that's a term we use internally, which is the least complex cause to explain the evidence we currently have, sort of Occam's razor. And a fact, something that really occurred, a truth. And I think conjecture and fact are often confused. And I came up with a phrase that I've used many times, and only one person has looked like they were going to punch me over the last 10 years, which is when somebody makes a statement and they're really holding on to it as if it is a fact, and I'm not so sure. So, okay, if you think that's a fact, and in future you turn out to be wrong, can my wife go shopping with your Visa card? And that, it kind of opens them, and we kind of make progress. It's been really useful. Now what they don't realise is, one, my wife is Scottish, and two, she doesn't spend much money. But I'm going to continue to bluff that. But that kind of Visa card, it's actually really important with performance, maybe more than anything else, because there are often performance seems to bring in multiple participants. Maybe it's because performance has a time element, and which, if a system panics, even if it's in a third-party driver, you've got better state to go and examine. You don't have the third dimension of time. You've kind of got data and execution and then time, but which performance has. So people can make statements more easily, which are conjecture rather than fact. And if you do use that and you're successful, let me know, because I thought it's quite funny. Okay, the next bit is single issues, say performance, tend to get solved quite quickly, even if they're quite hard. If there's just one issue at a customer site, then it gets solved really easily. You've probably heard my FISMEM story of going to France on Eurostar and coming back 2 hours later after lunch. And that was just, FISMEM setting, etc. system, and they just stayed there. One issue, really quick. Single issues are almost never the cause of long-running performance issues. And one of the things I find, I'm going to visit customers who are quite high-pressure situations, is that you kind of solve the first one, and they go, oh yeah, it's better. And you just sit there and go, right, there's another one coming. You know it hasn't been nailed. You have that feeling that there's at least one or two more issues. And this is really, I think it's one of the things, sort of the principles. It's not truth, it's kind of a principle, because most of the time it's true, is that your primary issue will obscure the performance issues behind. So sometimes you can have 5 or 6 settings or configurations, and you actually need, it's like getting, if you want an eclipse, you have to line the planets, the moon, and the sun up. And you don't get any improvement in performance unless you kind of do the sensible stuff and remove them all, and then you have this massive jump. So multiple issues, it's that one issue obscures the other, and sometimes you have to line them up to get the improvement. It's not always, well, if we fix this, oh no, it hasn't worked, let's not change that. So there's more complexity. But what can you do? You can take the first one and iterate. And sometimes this does require try and learn. So I was working with a customer recently, and we wanted to put some network performance issue. And we said, okay, let's put these 2 machines back to back. And we couldn't do it because it would be a trip hazard in the data center. It's like the machines there. No. And that probably extended the resolution time by weeks. Well, can't we do that of ours? No, it's a union shop. Okay. And sometimes we need to do this, sort of vary things to try and get something that has the problem and something that doesn't, the is versus is not, to try and draw a comparison. And that's why sometimes try and learn is the kind of fastest way. So I think there are 4 approaches to performance analysis. So lower part of the iceberg. So static configuration check. So you take somebody who knows, hopefully knows what they're doing, has seen is involved in the customer base, knows what has an experience of things going wrong, has been bitten by lots of different stuff, and you get them to go through an Explorer or whatever your configuration tools is, and try and really, the herd. So a colleague of mine, Tim Uglow, he came up years ago with the concept of customers are like wildebeest. No, they don't look like them, but the ones that get eaten by lions or get hit by bugs, performance issues, are the ones that stray out of the herd. So by doing what everyone else does, it kind of reduces the issues. And this is where the static config checking can be really valuable. It can be really cheap, very quick. We can find issues very quickly. But it's a bit pot luck in terms of who's doing it and getting the right person who's had that sort of experience. But if you have a performance issue, that's kind of where I would start. If it's kind of a business critical, that's the first thing I'd do, because it's likely 50% of the time to throw up the issue. Then we've kind of got a top-down approach. This is sort of nirvana. We will get to the root cause. We start with the business metric, whatever that is. We need to do so many transactions per unit time, and we work down the stack from our application through our database. Of course, we've got a database. Down through the various parts of the operating system, observing as we go, and trying to work out. But you have to have a business metric, and maybe it's just my blessed luck that most of the customers I've been involved with don't have any sort of business metric as to why their system, to measure performance. They just know. Is it going faster? Well, the users aren't complaining. They just know. So sometimes you just can't do this. You might look at an Oracle AWR report, but it's not relevant to the performance issue. So you can't always do top-down. And then, when there's no business metric, it's then down to bottom-up analysis. So taking things like VM-stat, MP-stat, IO-stat, PR-stat, looking for anomalies and trying to split the stack. The stack, up there, customer, and then application, middleware, database, operating system, CPUs, disks, and the stack, network, depending on where you're going. And we basically try and split. So, for example, we might use IO-stat, which is very low down, and we say, okay, are the IOs taking a long time? If we've got an IO, if it looks like we've got an IO issue, we might look at the system calls, we might probe up with dtrace, for example, the read and write system calls, try and get some insight into where in the stack. And this bottom-up stuff is all about stack splitting, in my philosophy of performance. It's but one of many. And then there's the bottom one, which seems to be a favourite, and it always seems to be the most responsive vendor. I don't know why, but it seems to be just painful and slow, and it extends the amount of time. So I think there's a case for picking the appropriate, maybe static config and something else, depending on the availability of a business metric, rather than this one. Because sometimes you're not shouting at the right vendor. We sit and go, I've been involved in issues where we've been shouted at, and it then becomes, we're trying to diagnose, let's say in the case of a network stack, we can only see from the NIC, and it's like, what's going on in the network, in the switch? I was involved in a case many years ago where they thought they were within the network was within the data center. I think it was actually IO, and it was being routed by Norwich. Oh, how do we know that? So if you are going to shout at a vendor, make sure you shout at them all. So there is some technical stuff to come. Don't worry. So long-running performance issues. They are so because generally there's rampant assumption making. And I've got another little saying is 10 minutes of observations can save months of speculation. And that's quite true, and that's, I think, where dtrace really kind of comes in, allows you to observe stuff. And we see commonly hurry up and jump to cause and a lack of patience. And again, it's just not saying, let's go and observe what's going on. An aversion to try and learn is that sometimes we do have to, these are not toy systems. Very few Oracle customers buy Oracle systems for a toy. They are used for serious business purpose. But unfortunately, sometimes you need to vary the parameters of operation to try and get some insight into splitting the stack. A lack of end-to-end observability. Involved in an issue recently where the switch vendor had taken, actually, it was the people who managed the switch had taken network traces and said, oh, there's nothing. And when they were required to re-examine them 3 or 4 weeks later, they found some issues. Lack of communication at multiple levels. It's quite common that we can not be told things. We say, oh, you've got problems with the Solaris machines. Your Solaris machines are the problem. Slow. And there's also IBM machines that are seeing the same sort of issues. And we don't get told that. And it can be very difficult to persist with questioning. So no whole stack view, sort of the holistic picture, and quite linked problem management. And it depends who takes on the management of the problem. I think vendors are normally quite good at doing it, unless they're being defensive. And I've not come across that many customers who are really good at aggressively driving the resolution of a problem. And I think that's something that vendors can really bring to the party. And very difficult, because often issues are not reproducible. So if we can just take an issue, you can tell us how to reproduce it. We'll put it in the lab, brilliant. We can then test our fix very, very quick. Where we would need to ship 200 SaaS users into the lab, that is very difficult. And I think there's also fear. And it's just a fear of changing stuff. A customer can have been beaten up by the regulators because their machines aren't meeting the requirements. But a fear of having either an outage can drive what's maybe not drive a behaviour that maybe isn't the best in hindsight. But they're not because vendors don't care. We clearly do. And you normally get people on site, it's their reputation, so there's a personal level of caring, and a company cares about the sale of the relationship. And it's not because people assigned by vendors are stupid. I've met few stupid people, though I have met some. And it's not that the problems are technically that hard. If they are, we've got some, like other companies, we have some very bright people who can come in, who we can bring in. And what an issue I was working on recently, I managed to get in a guy who sits on the TCP Standards Committee. That's really useful, and that would be typical if something gets escalated sufficient level. We can get hold of people like that. But problems typically are not that technically hard. It's the rest of the stuff. So, I thought I could start on the sort of more technical. I've done the hand wavy stuff. So now, I thought I'd tell you about VM2 tunables. All right. So if you're running Solaris 11 update 1, please, if you're doing anything psychopathic with it, update SRU 7, please. VM2 is it's a complex subsystem. It has had some teething problems. So please go to update 7. I think update 8 is just out. Well, okay, there is one. And one of the things that I've seen is